Okay, so I want to walk you through module 11's homework for the chi-squared distribution. So let's just talk a little bit about what is a chi-squared distribution. What does it give us? What is it telling us? Well, in general, what a chi-squared distribution is telling us is it's telling us about how good, how appropriate the goodness of fit of the sample data to the population. So what the chi-squared statistic tells us is basically it's a number that tells us the difference between the observed counts and the counts that you would expect if there was no relationships at all in the population. So we're looking at residuals. The residual being the difference between the observed and the expected, and we're trying to then use the size, the scale of that residual to try to say a simple statement about how appropriate or how close the sample data is, we think, to the population. I only want to say this because I was thinking of this just before this lecture. So I live in faculty housing over in Manoa, and it's all professors, and my family, we're six. There's six of us. So I'm coming home, and I can always tell what my house is because it's like the loudest one. I have all boys and they're loud and breaking stuff, and I'm like, oh man, look at all these other houses. They're all like super quiet. But as I'm walking up to my place, I can hear the neighbor having a conversation about like sample and population, and it sounds like a statistics lecture. So I open the door, get in my house, and I'm just like chit chatting, and I was like, oh, I think our neighbor is making a stats lecture. And my wife was like, oh, how do you know that? How do you know? I was like, well, either that or it was a very one-sided, boring statistics conversation on the phone, or he talks to himself in statistics. I say that because maybe someone's thinking that about me right now. Okay, let's look at these. So what we start off with here is that you have some understanding of how proportions are calculated. This should be a pretty simple one. Simply what you're doing here, and you can kind of see my answers here, what I'm simply doing here is I'm adding up how many individuals there are. So I simply summed up all of this and got this number. Then for females, I simply summed up that column and got that. This is always the hard one. Some of these I get wrong because I don't know how much they want us to round to. I don't really like Lumen for this reason, but anyway, this is how I rounded it and got this. And when it says the previous exercise, what it means is the previous question. When I read that at first, I was like, oh man, are we missing something else? What they mean is the previous thing. Here it's telling us the marginal distribution of sex or gender, depending on how you define it here. And it's basically saying, versus if you're female versus male, what your opinions are going to be. And that's your conditional. If you are certain to be married, based on that condition, what percent of those are females, which is why we're saying it's a conditional distribution of opinion about marriage among women. These all refer to something that I do not know what they refer to. It's not terribly important here, because you're going to get that from here. Again, I have the same problem here. In terms of rounding, looks like it wants to do 3 digits maybe, or maybe 2 digits. Looks like in column, it looks like for row A they want you to do 3 significant digits, and for row B it wants you to do 2. Okay, so how would I calculate this? And you know how I would calculate this is based on the idea that I'm going to put this data into my chi-squared calculator. I just got this one from chi-squared calculator from Social Science Statistics, and wow, apparently it really thinks that I want to go on Chegg and look up my answers and cheat. But that wouldn't be good because then you wouldn't learn the material. So in this chi-squared from SociSciStatistics.com, I just typed in my numbers here. Typed in next. Okay. You can do it at the 0.05 significance level. Now, I'm not going to go there yet because this table that they created for us is actually pretty helpful. Because going back to here, if we want to calculate the expected values, well, what the expected values are for each of these, the process of calculating the chi-squared distribution, the expected values are pretty important. And to get each of these expected values, these four values we're looking for here, we're going to take the row total times the column total over the n. Which means I'm going to take row total, 97, times column total of 80 and divide it by 231. And when I do that, I get 33.593. Let's just do this one here. I'm going to take sorry, let's just do a different one here for 46. So for 46, I'm going to take 134 over 80, 134 times 80 divide by 231. It's going to give me the 46.4. And so I do that for each of these. Now, Pearson residuals, if I were making you in statistics calculate everything by hand, these Pearson residuals would be pretty important. But honestly, because I've made the decision already in this course that I'm not going to hold you responsible for calculating things by hand, you can ignore this. I will give you credit for it. I didn't round appropriately here. Anyway, what you think I got wrong. But the Pearson residuals are pretty complicated. They're going to take you a while to calculate, and there's no calculators really online for you to calculate this. So you would have to do it all by hand. I want you to ignore it. I'll send out an email about this as well. But then for our chi-squared distribution, or our chi-squared test statistic again, what this is now going to say is this is going to be a measure of how close is our sample data to the population data. So let's look at what that is. 0.013. With a p-value here of 90% of the values. We know what p-values are from the previous modules. Now, what we can kind of see here is that when we're going to report it, what we do is we use the chi-squared distribution test statistic to then say something about whether at a certain significance level, whether we think the data, the sample data is close to the population. In this case here, we'd be talking about the association between populations and categories here. Okay, so you're just going to repeat that for this right here. I'm not going to do this, but again, you can skip the Pearson residuals. Degrees of freedom. Let's just talk about what the calculation is for this. That would be your number of rows minus 1 times your number of columns minus 1. So 6 minus 1 times 6 minus 1 gives you 5 times 5. That's your equation for degrees of freedom. And then over here, to solve number 8, I basically just started writing out a, again, you're calculating proportions like you were in the very first question. So what you're doing here is, when you read the question slowly here, so if I want to say, what fraction of survey respondents are Democrats? Well, all of the survey respondents are the summation of all of these numbers. So then I would take this row, sum up this row, which in my case ends up being 236. And I'm going to divide that by 651, which is the summation of all this. And that's how I got this. And you would just keep going through this here. And the final question is definitional. And it's really just talking about the conditional aspect of the fact that if you are Republican, Democrat, or none, are you the same? Conditional. So conditional means if, then. Because it's conditional, right? To meet the then, you have to be part of the if. Okay. That wraps up. Hopefully the module 11 homework should not take you too long.